All right, I'm not quite sure what just happened there, guys. I apologize. This is just part two of the video. Yeah. So tell you what. Let's go ahead and use these algebra tiles. I kind of changed my mind on that one. I want to show you how this is modeled, and then we'll kind of report a final answer to it. And we'll do both. So definitely we'll work this problem, and then we'll get maybe a sense of how to work this. So if you think about this first one, we just have 5, and those 5 are positive. So we have 1, 2, 3, 4, 5 for this one. Then we have to add, hence the plus sign here, right? 2 negatives. So here's a negative and here's a negative. So if you think about this, if you have a positive and negative together, as many people have said today, they kind of form a zero pair, and essentially they're canceled. Those have no longer have an effect on my problem because those two become a zero. So in the end, what we're left with is just 3 positives. So the answer to this has to be a 3, or in this case, a positive 3. Okay? Let's see that again. So we're looking at this -2, and this -2 is going to contribute 1 negative, 2 negatives, kind of like a -1 and a -1. Then we're going to add 4 positives. So that's like a +1, a +1, a +1, a +1. So now if we kind of take away 0 pairs, those would become a 0, and these guys would become a 0. That should leave us with +2. So if I have -2 plus 4, this should be a +2. Again, shall we? So we have a 3, positive in this case, so that's a +1, +1, +1 for the 3. If we look at this -4, now here's where it gets interesting, because we got to take away 4 negatives, but to have negatives to take away, we have to add them first. So check this out. I'm going to add a +1 and a -1, a +1 and a -1, a +1 and a -1, and a +1 and a -1. Now, if you're asking me why I'm doing that, remind yourself, if I have a positive and -1 together, those two together are going to form a 0. So what I've essentially done in this green area is add 4 zeros. But what I've really done now is give myself some negatives to take away. So I have to take away 4 negatives. So I'm going to take away these 4 negatives. Boom, they're gone. And look what I have left. 1, 2, 3, 4, 5, 6, 7. Okay? Now before you freak out, stop and think for a second. Think about problem 1. Negative and a negative really make a positive, so essentially this was just 3 plus 4, which of course is 7, so it does work out. In fact, we can kind of do some pre-work here. We have a -1, -5. That's a -1 plus 5. That's going to give us a +4 for a final answer. But let's go ahead and work it out piece by piece. That's going to give us that -1. So if I want to take away 5 negatives, I first have to add them. So -1 plus 1, so +1, -1, +1, -1, +1, -1, +1, -1. Now I actually have some negatives to take away. So I'm going to take away these 5 negatives, which leaves me this as a 0 pair. So that should be 1, 2, 3, 4. So +4 is my answer. Now that part might warrant you kind of like rewinding, watching it again, but certainly this is the way you can model this addition as well. So here they specifically want us to model it using a number line. So again, let's think of this one piece at a time. So let's start it in -4. And then I want to go 6 in the positive direction. 6, of course, because in the plus. So 1, 2, 3, 4, 5, 6. So we should end up at a positive 2. Here, let's start at 8. And then I want to add 3 negatives. So I want to add 3, but in the negative direction. So that's 1, 2, 3, because of course this side's negative, this side's positive. Hey-oh. So we end up with a 5. Okay, here we're going to start at a -2. Because right here we have a -2. And then we're going to add 7 in the negative direction. Of course, this side's the negative direction, positive direction, so that's 7. So 1, 2, 3, 4, 5, 6, 7. Boom, we end up at a -9. All right. Next, rewrite -6 plus a -4. I'm sorry, -6 minus a -4 as addition problem, get the final answer, and then model it. Okay, well, first of all, let's do that. We have these 2 negatives. So we have -6 plus 4. Now we need to model on the number line. Let's start at the -6. Boom. And then let's add 4 in the positive direction. So 1, 2, 3, 4. That gives us a -2. Oh, okay. Now we just have to solve each of these problems. We have these models on the first page if you want, but we can also use logical models too. That's okay to do as well. So think about it like this. Let's say I owe Mr. Bostwick 20 bucks, and he's like, Mr. Gonzalez, give me my money. And I said, well, I don't have all your money, but I do have 8. So I owed him 20. I paid him back 8. How much do I owe him now? Well, I should owe him 12 bucks. Negative because I owe less than 20 because I did pay some back with a plus 8. Here we can probably use some of our good rules that we had before. We kind of developed in this lesson. So we do have these two negatives. So think of it like a positive. So I have 10 plus 10. That should give us 20. Here's a good example of like borrowing money again, right? So let's say I go up to Mr. Bostwick and I owe him 16 bucks. And I'm like, hey, Mr. Bostwick, can I borrow another $17? And he's like, yeah. And so how much do I owe him now? Well, I had owed him 16. Now I'm going to add more debt of 17. So that should be, what, 33 bucks? So negative implies I'm still owing. Here's an opportunity for a rule again. We have two negatives. That's going to make a positive. So we have negative 5 plus 20. So this is like it was negative 5 degrees out, and then it went up 20 degrees. It should be positive 15 degrees. Is negative 17 degrees out and went up 5 degrees? Well, it's a little bit warmer, but not too much. We're at negative 12. 7, then add 5 negatives, so it gives a positive 2. Rule opportunity. Hey, plus sign. 6 plus 4 is 10. $1 in my bank account. Write a check for $13. I owe 12 bucks. Next. All right, staying sharp. So shape equation puzzles. You gotta love these. I mean, by now you have to be loving these shape equation puzzles. I know I do. But they are getting tougher. I mean, they really, really are. And it's always been about the point of entry. So if I'm looking at these three equations, I'm asking myself a very critical question. That critical question is, where in the world do I start? This one is really a no-go because I have a triangle and a square to make a 13. There are way too many combinations of triangle and square to make 13. Same thing with square and diamond. I just don't know. So my entry point is actually going to be equation 1. Now here's the reason equation 1 is going to be my entry point. Check this out. Triangle plus something is triangle. Well, if triangle is a number, what's the only number I could add to something and get itself? Tick-tock, tick-tock. That's got to be 0. So diamond, it's got to equal 0. It has to. It has no choice. Because if I have a triangle and I add a 1 to it, I have not a triangle. If I have a square and add 1 to it, I have not a square. If this is like a 5 and I add 6 to it, I don't have a 5 still. But if that's a 0, I can certainly add anything I want to it and end up with it, what I had. Because 0 is what we call an identity. It doesn't actually matter. So let me clean this up a little bit. Boom. Okay, so I'm going to put a 0 here for the diamond, which of course means that diamond's 0 as well. Wait a minute, look at that. That means a square has to equal 6 because square plus 0 is equal to 6. And if square is equal to 6, ayo, a number plus 6 is 13. That means that number, that triangle, has to be 7. Okay, so that's going to be triangle is 7, diamond is 0, square is 6. Square box problem. Oh, I told you you're going to see these again. Just for an issue of review, if I take these two numbers together and I add them, I get the bottom. If I take these two numbers and I multiply them, I get the top, all right? So it doesn't really matter which one you do first. Let's just do the top because I'm still in blue ink, but I have 11 times a negative 3. First of all, you know the answer is going to be negative. 11 times 3 is going to be 33. And I'll jump to the bottom. 11 take away 3, so 11, 10, 9, 8. I did do that with my fingers, by the way. I still use my fingers for a lot of math. Gives us 8 for the bottom. Okay, the amount of protein a person needs each day is proportional to his or her weight. Proportional is an important thing. That means the more someone weighs, the more they need. The less someone weighs, the less they need. So Rod weighs 165 pounds and needs 60 grams of protein each day. If Todd weighs 220 pounds, how much protein does he need each day? So there's lots of strategies to have you guys work this, but I'm going to go ahead and show you the one I prefer you guys to use. We're going to have something called a proportion. So we're basically it's going to be two fractions we know have to be equal to one another. So we had 165, and this guy needs 60 grams of protein. That should be in the exact same ratio, in other words, exact same fraction, as someone who weighs 220 pounds, needing some unknown number, which I almost mark as a question mark, if that's okay. Now, thinking back to 8th grade, and I know you've done this, we're going to do something called cross multiplication. So 165 times some number I don't know, which is still a question mark, is equal to 220 times 60. And I don't have a calculator on me, so I'll just do this by hand. Oops, that's a 0. 6 times 0 is also 0. 6 times 2 is 12. Carry the 1. 6 times 2 is still 12. 13. Okay, so this is going to be equal to 13200. Now this is multiplication, so again, thinking back to 8th grade, we'll divide by 165, divide by 165 here as well. So now we got to do, oh, that's so messy. Let me fix that. Okay, so it'd be 13200 divided by 165. Okay, and that one I'm afraid I will need a calculator for, so I'm going to get my phone out. Okay, so if I take 13200 divided by 165, I end up with 80. Okay, so in this particular case, this guy will have to eat 80 grams of protein a day, which is quite a bit. Okay. That's like 4 big chicken breasts. That's quite a big protein. All right, sketch a rectangle and label its dimensions. That is, and that's what label its dimension means. It's telling you right here, that is, write the numbers for its length and width. That meets the following conditions. Perimeter is 18, area is 20 square meters. Okay, so here's the deal. This is actually not all that different from that square box problem, the magic box problem, if you will. The area being 20 square centimeters tells me something really important. Whatever this number is, times whatever this number is, the length times the width, does equal 20. So if I'm looking for a number times a number to make 20, I can just make a list. I know that 4 times 5 is 20. I know that 10 times 2 is 20. And I know that 20 times 1 is 20. Okay. Now the question is, which of those is going to make 18 centimeters for a perimeter? And now the thing to really keep in mind is that the perimeter is an addition of all 4. Okay? So one strategy I know we developed is guess and check. So I'm just going to do that. Let's say it's 10 and 2. Because 10 times 2 does equal 20, so that fits this condition, so we're good. That means this side has to be 10, this side has to be 2. Well, check this out. 10 plus 10 is 20, plus 2 is 22, plus 2 is 24, excuse me. That's too much. I only needed 18, so that's definitely not the right answer. In fact, I got to pick numbers that are a little bit closer together if I ever have a hope of making those numbers come out the way I want. Well, I only have a couple choices, and I know I need to get them closer together. So the answer in my mind is probably going to be 4 and 5. So if I put 4 and 5 here, the area is still 20, so we are still good. Make a 4 over here and 5 on this side simply because it's a rectangle. Well, check this out. 5 plus 5 is 10, plus 4 is 14, plus 4 is 18. That's what we got, so 5 and 4. Now, we do want to check. This does have centimeters, so we want to go ahead and make that label centimeters. And we can move on. Round each number to the nearest integer. That means the next nearest a whole number, and in this case, because they're all positive. So think of this like money. If you take something that costs $11.90, that's pretty close to 12 bucks. 549. Now this one's tricky, but if we're rounding to this, we got to use this as its rounding element. So 549, we're going to actually round down to 5. 709. Well, that's pretty close to $7. And $8.50. Now this is the rule we round up because 5 kicks it up, we'll make it 9. Okay, so we have 12, 5, 7, 9. Final problem: you can find the volume. You can find the volume of a rectangular solid. It's telling you by taking the length times the width times the height. Remember, those dots are multiplication. Find the value of the rectangular solid here. So length would be this guy. Width would be 5, and then this guy we'll call the height. Okay, so if the volume formula is width, yoink. The volume formula is length times width times height. We should have 7 times 5 times 3. Now let's multiply this out. You guys established today multiplication order doesn't matter, so I can do this any order I want. I'm going to go ahead and do 7 times 5 and get 35 times 3. Now let's work that out here. We have 35 times 3. 3 times 5 is 15. That's 9 and 10. So the volume in this case is 105. And it doesn't give us units, so we'll just leave it at that. Volume is 105. Alright, guys, that's a pretty long video. It's 2 parts, so please be patient. Make sure you watch them both. If this helped you, hey, why don't you get someone in the class to watch it with you, maybe study together, spread the word, alright? So thank you guys for watching. Have a good night, and